All right, students. So today we're going to talk about convergent plate boundaries. And listen to the term convergent. Converge, that simply refers to two entities or two objects which are in fact moving towards each other. A plate is in fact what? A piece of the Earth's crust. And obviously, as we mentioned previously in class, a boundary is in fact a region or an area where two or more plates interact. So that being said, students, a convergent plate boundary rather, is in fact an area or region where two or more plates, right, interact or move towards each other. Okay. Now there's in fact more to this. Sometimes, most of the times, you actually would have plates belonging to different densities. We mentioned earlier that oceanic plates are in fact those which are in fact denser than continental plates. Okay, so in terms of a convergent plate boundary, we should bear in mind that the oceanic plate would in fact subduct or sink. All right, so if we were to look specifically at this particular image on the screen, all right, just remember the asthenosphere is the upper parts of the mantle. Okay, so observe something for me quickly. This here is in fact the oceanic crust. Because of the weight of the oceans, or the ocean rather, it is in fact thinner, yet it is denser than the continental crust, which appears to be thicker. So when both of them, look at the arrows, when both of these crusts simply move towards each other, good. The objective here is that they are moving at great propensity towards each other. And what happens is that the denser crust or the denser plate will tend to sink or subduct. Where does it go? It goes below the continental crust and basically it extends further into the mantle. Now, since we understand the mantle is the area where you have a lot of heat and pressure, and it is in fact molten materials existing there, temperatures are very high, and this particular crust, which is subducting, right, tends to basically become molten, become dissolved, becomes broken down. And what happens is that the silica content from that crust is added to the molten materials or that pool of magma, which exists within the mantle. All right, now students, what happens? Pressure builds up eventually. And when I say eventually, we are talking about perhaps hundreds of thousands or even several decades, perhaps. It depends. All right, so we must bear in mind that pressure builds up and eventually it rises, it festers all the way up to the surface. And the pressure rises onto the surface where eventually the molten materials tend to escape on the surface of the land. All right, this feature here is in fact what you call a volcano. We can talk about it just now. Okay. Now, all right. So what I want to show you here are some, in fact, examples of converging plates. All right. Now, this one-day Fuca plate essentially converges with the North American plate. All right. That is an example of one example of two plates which converge, or an example of two converging plates. We also have the Caucasus plate converging with the Caribbean plate. And class, we also have the Nazca plate converging with the South American plate. Okay, so these are examples of converging plates. All right. There are in fact a number of features that we can in fact observe that are associated with convergent plate boundaries. And one of them do include that of volcanoes. As you can see from the image on the screen here, we basically have volcanic activity when the molten materials rise onto the surface, okay, and then eventually erupts. Good, as you can see from that. So volcanoes are in fact one of the very distinctive features which can be associated with earthquakes. I'm sorry, which can be associated with convergent plate boundaries. Sorry. All right, students, we also have volcanic island arcs. And the question is, what are volcanic island arcs? They are in fact created when the molten materials rise onto the surface through the same volcanic activities and eventually spread out and eventually cool and solidify to form a landmass. All right, as you can see, this is one, this is also one. And as time progresses, these same volcanoes can eventually become either dormant or perhaps extinct. All right. And what happened is that they will actually form the surface of land masses, where you can actually see in this region here, vegetative cover may tend to form in the outer regions of the volcanic cone. And as time progressed, this same structure would be sculpted with processes of, weathering and whatnot, breaking it down, So all these are in fact a succession of these would technically create volcanic island arcs, or a chain of islands which are in fact created by volcanic activity. And thirdly, we have trenches. Now, class, look carefully at this particular area here. This oceanic crust is converging with another crust here, right? And this crust is subducting. And this little section, this little deep, as you can see, is a trench, which exists at the point where the subduction takes place, extending all the way down along the both sides of the plates. All right, this is what you call a trench at a convergent plate boundary. So we also have deep sea trenches, which exist primarily below the oceans themselves. All right, so just to highlight these things, I will share some examples of trenches as a matter of fact. Students, look very close to this particular image. It's a very simple diagram, a very simple image which shows the volcano represents the landmass. As you can see, it's above the water. The oceanic plate is in fact going down or subducting. Look at this trench. Why is it called a trench, or a deep sea trench as a matter of fact? Look at the depth of the water from the surface all the way down to where it exists at the point where the two plates are in fact subducting. All right, it's a very deep section. All right, that's what I call it, deep sea trenches. Now, students, I always like to use Google Earth as a nice little tool in geography, right? And first of all, let's look at some of the volcanoes, right? Some volcanoes of volcanic landforms, right? Not necessarily landforms, but about the distinctive volcanic cones themselves. All right, so certain volcanoes which are associated with convergent plate boundaries, we have Mount St. Helens. All right, if you look carefully, Mount St. Helens is situated in North America. All right, and this particular volcano is on the western fringe of North America. As a matter of fact, it is considered to be a stratovolcano. Very explosive, as a matter of fact, in the past. It was very destructive several decades ago. We will talk about this when we're doing volcanoes later on. All right. Apart from Mount St. Helens, we also have Krakatoa. All right, and Krakatoa is in fact situated in Indonesia. But in 1883, all right, it erupted, and what happened is that it was very, very destructive, and the entire top of the cone was literally blown off the face of the earth. Now, what we have is in fact what we call Anak Krakatoa, which is referring to the son of Krakatoa because it is much smaller and it is developing very, very quickly since the previous volcanic eruption of Krakatoa in 1883. All right. Apart from that, we also have in the Philippines we have Mount Pinatubo. All right, and Mount Pinatubo is situated in an area in the Philippines called Luzon. All right, so pay attention. You can see these. This is a nice little tool you could utilize in your learning as well, which is Google Earth. All right. This is also was in fact a very destructive volcanic eruption which occurred in the past. Now, these are three distinctive volcanoes which occurred in the past, and they were in fact very much associated with convergent plate boundaries. All right. All right. Now, students, one of the most distinctive places where you have the most amount of volcanoes, and it is in fact the Pacific Ring of Fire, which is situated in the Pacific, as you can see on the screen here right now. Now, this particular area is in the Pacific, as we know fully well, and there is in fact the majority of volcanoes in this little section. This little red section you see shaded on the screen, extending from the western fringes of the Americas, both north and south, even extending towards the Asian continent, on the fringes of the Asian continent, as well as the sections bombarded the regional territory of Australia. All right, so this particular area is what they call the Pacific Ring of Fire. Okay, students, so when we're looking for specific areas in terms of volcanic island arcs or chain of islands, all right, we must take whenever you're talking about these chain of islands associated with convergent plate boundaries, you must first think along the Aleutian island arcs, or the Aleutian Islands. All right, and the Aleutian Islands situated primarily here. Right, if you look in the screen properly, you will see There are in fact a group of islands extending from the northwestern fringe of North America towards, well, this is Russia here, all right? And it extends outwards. Okay, so the Aleutian Islands are in fact these islands here, and these are in fact associated with convergent activity or convergent plate boundaries, as a matter of fact, because these islands extend all the way down, all right, across towards the eastern hemisphere. Okay. Also, usually what I like to highlight also is in fact the Caribbean islands or the Caribbean island arcs. And that is actually very important because we are in fact from the Caribbean, and we know fully well that these Caribbean islands are associated with convergent plate boundaries as well. Now, this, zoom in a little bit, this region here, this little cut or this section of a whole array of islands just swinging all the way down, this is a chain, all right? This is in fact associated with convergent plate boundaries as well, all right? Keep that in mind, okay? In terms of trenches, right? Remember we spoke about the Aleutian Islands, all right? Let me show you where these trenches exactly occur. We have some examples of very distinctive trenches, and the Aleutian Trench is a very important one. This dark coloration that you are seeing here on the screen simply represent right here, simply represent a very distinctive area where plates are in fact converging. This here is the Pacific plate, all right? This here is in fact the North American plate, and here is in fact what you call the Eurasian plates. We have three plates interacting, and this trench, this dark section here, is in fact what you call the Aleutian Trench, just at the fringe or the edge of the Aleutian Islands. We also have the Mariana Trench, right, which is a very, you will most probably hear this one very, very often, as a matter of fact. And we can see this trench is in the Pacific as well, or below the Pacific Ocean rather, and it is situated on the eastern fringe of the Philippines. All right, the Mariana Trench. All right, class, we also have the Peru-Chile Trench. I was trying to type it in here so you'll be able to see it properly. All right, the Peru-Chile Trench is in fact a very distinctive one in South America, as you can see on the screen. This little dark coloration here, this whole region here represents an area where South America converges with the Nazca Plate. This dark blue represents a deep body of water. All right, that is in fact the Peru-Chile Trench in this region here. Okay. All right, on the eastern part of Australia, well, east of Australia rather, all right, this is Australia here, there is also the Tonga Trench. All right, this Tonga Trench here is a very deep region as well, extending towards New Zealand. Now remember, these trenches are primarily associated on the edges of the Pacific Ring of Fire as well. All right, so the Tonga Trench is also a very important one. All right, students, I hope that was actually helpful for you all, because we spoke about generally the majority of convergent plate boundaries. We talk about the thin oceanic crust subducting into the mantle below the continental crust, which is thicker. We talk about some features associated with the convergent plate boundaries. We mentioned volcanic island arcs. We also mentioned deep sea trenches, which occur in the deeper part of the water, the deep body of water as well. We also talk about the subduction zone here. All right, we mentioned the crust, which has become reabsorbed into the mantle. Pressure builds up. That is why you get volcanic formations as well, which was not mentioned in previous minutes in this video, was in fact that of accretionary wedges. These are in fact simply sediments and pressurized rock fragments from the ocean seabed, as well as from the land, kind of mixing together to create a pool of a little looser materials, all right? But this is nothing big associated with your syllabus at this point in time, all right? So just remember the main some examples of converging plates, all right? We highlighted that. Make sure you remember some of the examples of each of the features that we may have mentioned, so keep that in mind as well. And in next class, as a matter of fact, we'll be in fact going through some of the diagrams, as well as finishing up some of the remaining notes for the other chapter as well. Okay, all right, students, you keep safe. Take care.